Introduction: The Eternal Traveller, Halley's Comet. The night sky has always fascinated humanity. For centuries we have gazed upward, seeking meaning in the vast expanse of stars. Among the celestial wonders that have captured our imaginations, Halley's Comet stands as one of the most iconic and mysterious. This comet, which has visited our skies for millennia, is a celestial wanderer that has played a significant role not only in the history of astronomy, but also in the history of human thought. Its recurring presence has been witnessed by countless generations, stirring awe and curiosity with each return. In the year 1705, a brilliant English astronomer, Edmund Halley, made a discovery that would change our understanding of the cosmos. He observed that the comet, which had appeared at regular intervals, was not a random occurrence, but rather a predictable event, a visitor from deep space that returned to our skies in a cycle. Halley's insight into the periodicity of the E-Mahi comet was groundbreaking. He recognized that it was the same comet that had appeared in the years 1531, 1607 and 1682, and he predicted that it would return again in 1758, a prediction that would prove to be true after his death. Halley's contribution to the study of comets and his pioneering work in understanding their orbits laid the foundation for modern astronomy. His work not only earned him a place in the annals of scientific history, but it also reshaped our understanding of the universe itself. In this audiobook, we will take a journey through time, exploring the life and work of Edmund Halley, the theory, significance of Halley's Comet, and its role in the development of scientific thought. Through the lens of Halley's groundbreaking discovery, we will delve into the mysteries of comets, the cosmos, and the ever-changing sky above us. Join us as we embark on a voyage of discovery, where science and history intertwine, and the wonders of the universe unfold before us like the tail of a comet sweeping across the heavens. Episode 1: A Child of the Stars, The Early Life of Edmund Halley. In the quiet town of Haggerston, just outside of London, Edmund Halley was born on November 8, 1656. The world he entered was one still shaped by the turmoil of civil war and religious tension, yet also on the cusp of a great scientific awakening. As the son of a prosperous soap maker, Halley grew up in relative comfort, his family's success affording him a rare luxury for the time: a proper education. From a young age, Halley showed an unusual fascination with the night sky. While other children played or studied more conventional subjects, Edmund would gaze upward, charting the movement of stars and planets. His father, recognizing this unique passion, supported his interests by providing him with books, instruments, and the encouragement to explore the unknown. Halley's intellectual journey truly began when he entered St. Paul's School, where he quickly distinguished himself in mathematics and astronomy. By the time he reached Queen's College at Oxford in 1673, he was already making a name for himself as a prodigious student of the heavens. At Oxford, Halley formed relationships with some of the greatest minds of his time, people who were shaping the scientific revolution itself. One of the most important of these connections was with the renowned mathematician and physicist Isaac Newton. Their relationship would later prove pivotal in the advancement of astronomy and in Newton's own rise to fame. But before these towering achievements, Halley set out on a journey that few men of his age could imagine. In 1676, at the age of Just 20, Halley left Oxford without a degree, choosing instead to pursue a greater calling. He travelled to the remote island of St. Helena in the South Atlantic Ocean, commissioned by the Royal Society to make detailed observations of the stars in the southern hemisphere. Stars that had remained largely uncharted by European astronomers. There, on the windswept cliffs of a volcanic island, Halley battled isolation, harsh weather, and the limits of his equipment. Yet his work was extraordinary. He catalogued hundreds of southern stars with an accuracy never before achieved. His observations would become known as the Catalogus Stellarum Australium, published in 1679, and they solidified his place in the scientific community. Upon returning, May, to England, Halley was hailed as the Southern Tycho, a reference to the famous Danish astronomer Tycho Brahe. He had accomplished more in his early 20s than many did in a lifetime, and his passion for the cosmos only grew stronger. This first chapter of Edmund Halley's life was marked by curiosity, bravery, and a determination to seek truth beyond the limits of known knowledge. It is a reminder that the great voyages of discovery often begin not with a ship or a telescope, but with a single question and the courage to follow it through the darkness. As we continue, we will follow Halley into the heart of astronomical history toward his momentous prediction of a comet's return and the impact that would echo through centuries. Episode 2, The Southern Sky. Halley's voyage to St. Helena. The year was 1676, and the Royal Society, ever eager to expand the boundaries of knowledge, had a bold idea. Much of the southern hemisphere's sky remained a mystery, its stars uncatalogued, its constellations only vaguely known to European scholars. To change that, they turned to a young and ambitious astronomer, Edmund Halley, then just 20 years old. With support from King Charles II, Halley secured passage aboard a ship bound for St. Helena, a volcanic island in the South Atlantic Ocean, far removed from the bustle of Europe. The island, known mainly as a remote outpost, offered a rare vantage point, a clear and stable view of the southern stars. The journey itself was not simple. Crossing the equator involved both physical hardship and navigational challenges. Halley had to bring with him not only a telescope and other instruments, but also the fortitude to endure isolation, humidity, and long nights under uncertain weather. Arriving in St. Helena in late 1676, Halley began his observations almost immediately. He constructed a modest observatory and began systematically charting the heavens. Though the sky was often clouded by the island's tropical climate, Halley remained persistent. Night after night, he documented the positions of stars that had been largely neglected by European astronomy. He focused his efforts on cataloguing what would become 341 southern stars, a number unprecedented at the time. His methodical approach combined mathematical precision with a deep reverence for the cosmos. He used a sextant and a telescopic sight, tools that allowed him to improve upon earlier, cruder charts. The young astronomer's results were so precise that many remained useful for decades. While on St. Helena, Halley also observed the transit of Mercury across the Sun, an event that only occurs about 13 or 14 times each century. His accurate timing and measurement of the transit helped lay groundwork for future methods in measuring astronomical distances, such as the Earth's distance from the Sun. But the voyage was not only about science. Halley's letters from the Audiobook island reveal his personal reflections about solitude, about the awe of the night sky, and about the privilege of witnessing a world few had ever seen. His writings carry the quiet humility of a man who understood that he was part of something much larger than himself. When Halley returned to England in 1678, he brought with him the manuscript of the Catalogus Stellarum Australium, or Catalogue of Southern Stars. The Royal Society quickly recognised the value of his work. So impressive was his contribution that despite having left Oxford without graduating, Halley was awarded an honorary Master of Arts degree by royal command. With this, Halley became known not only as a rising astronomer, but as an explorer of the stars, an individual willing to travel thousands of miles and endure great hardship in pursuit of celestial knowledge. He was, in a sense, a cartographer of the cosmos, mapping the invisible and giving order to the unknown. This journey to St. Helena was more than a scientific expedition. It was a declaration of purpose. Halley had proven himself on a global stage, and the astronomical community would never see him as merely a student again. The stars of the southern sky had spoken, and Halley had listened. Episode 3: Friendship and Genius, Halley and Isaac Newton. As Edmund Halley returned from St. Helena, and his fame began to grow, so too did his curiosity. He was no longer just an observer of stars. He was becoming a thinker, a theorist, and a catalyst in one of the most important scientific revolutions in history. And at the heart of this revolution was a name already whispered with respect in Cambridge and London: Isaac Newton. In the early 1680s, the question of planetary motion was stirring minds across Europe. Johannes Kepler had described the elliptical orbits of the planets, but no one could fully explain why they moved that way. The forces behind the motion remained mysterious, cloaked in mathematical riddles. One day in 1684, at a meeting with fellow scientists Robert Hooke and Christopher Wren, Halley posed a simple but profound question. What kind of force keeps the planets in their elliptical orbits around the Sun? Hooke claimed to have the answer, but couldn't produce the proof. Unsatisfied, Halley made a journey to Cambridge to visit Newton, who had retreated into a life of quiet contemplation. When Halley asked him the question, Newton replied casually that he had already calculated it years ago. The force, Newton said, was inversely proportional to the square of the distance between two bodies, what we now call the inverse square law of universal gravitation. Halley was stunned. Could it be that the answer to one of nature's greatest mysteries had been sitting in Newton's study all along? Eager to see the proof, Halley encouraged Newton to write it out. In the months that followed, Newton expanded on the idea, linking the motion of the moon, the tides, and even comets to the same universal force. The result would become one of the greatest scientific works ever published, the Philosophia Naturalis Principia Mathematica, or simply the Principia. But there was a problem. Newton had no interest in dealing with the complexities of publishing, and the Royal Society, strapped for funds, could not afford to print the work. Halley, recognizing the manuscript's profound importance, took matters into his own hands. He personally funded the printing of the Principia, ensuring it would reach the world. More than just a supporter, Halley acted as editor, mediator, and encourager. He helped Newton refine the presentation, managed the logistics, and even diffused tensions between Newton and Hooke, who was bitter over credit. Without Halley's unwavering support, the Principia might never have seen the light of day. In 1687, the book was published, and it changed the course of science. Newton's laws of motion and gravitation provided a framework that could predict the movements of planets, moons, and projectiles alike. The cosmos had been reduced to mathematical elegance, and Halley had helped make it possible. This chapter of Halley's life reveals more than just intellectual brilliance. It shows his humility, his belief in collaboration, and his instinct for recognizing genius. Halley did not seek to overshadow Newton. He was content to be the one who made the work happen, a silent force behind a great awakening. Their friendship endured, even when Newton became president of the Royal Society decades later. Though Newton would eclipse Halley in fame, Halley's role in the story of science is foundational. He wasn't just the discoverer of stars or the predictor of comets. He was also the spark that lit the fire in one of the greatest minds in human history. As the universe revealed its patterns, Halley stood not only as an observer, but as a guiding light, ever steady, ever curious. Episode 4, Mapping the Skies. Halley's contribution to star catalogues. After the monumental success of the Principia, Edmund Halley could have rested on his laurels. He had already voyaged to distant lands, charted the stars of the southern hemisphere, and played a pivotal role in the publication of Newton's masterpiece. But Halley's mind was not one to idle. The heavens still held secrets, and he was determined to illuminate them, literally. At the heart of Halley's lifelong mission was a desire to understand and organize the sky. In an age before photography or satellites, astronomers relied entirely on meticulous observation and detailed star charts. Halley's early expedition to St. Helena had given him first-hand experience in this discipline. Now, with greater resources and a growing reputation, he aimed to expand and refine the celestial maps that guided sailors, explorers, and scientists alike. In 1679, not long after his return from the South Atlantic, Halley published his Catalogus Stellarum Australium, or Catalogue of Southern Stars. It included over 350 stars previously unrecorded by European astronomers, marking one of the first major contributions to southern celestial cartography. This was no small feat. He had worked in adverse weather, with primitive instruments at sea-level altitude. But Halley's determination and precision prevailed. Later, as he continued his work in England, Halley became deeply involved in improving maps of the Northern Hemisphere's stars as well. He didn't merely rely on previous observations, he checked and corrected them. One of his most notable discoveries came in 1718, when he compared his measurements with those recorded by the ancient Greek astronomer Hipparchus and the 16th century observer Tycho Brahe. To his astonishment, he noticed that some of the brightest stars had changed position over time. Halley had stumbled upon a phenomenon now known as stellar proper motion. The idea that stars are not fixed points in the sky, but are in fact moving across the galaxy at measurable rates. It was a groundbreaking realization, though the changes were subtle. often only a few arc-seconds per century. They revealed that the night sky itself was not static. The cosmos, it turned out, was a dynamic, evolving system. Halley's contributions didn't stop there. He created some of the most accurate and detailed astronomical tables of his time, allowing others to predict the positions of planets and stars with greater confidence. These tools were vital for navigation and for refining scientific theories. Moreover, Halley's efforts in mapping went beyond the stars. He was one of the first to use isoline maps, lines connecting points of equal value, to chart variations in Earth's magnetic field. His 1701 map of magnetic declination was a milestone in geophysics, helping sailors adjust their compasses and paving the way for the science of geomagnetism. What sets Halley apart in this field is not just the data he gathered, but the vision he had for collaborative knowledge. He believed that scientific progress depended on accurate records, shared openly and improved continually. This spirit of openness and precision, deeply embedded in Halley's star catalogues and maps, would inspire generations of astronomers to come. He had gazed at the stars from remote islands, from crowded observatories, and from his own backyard. No matter the setting, Halley remained committed to the quiet, meticulous labor of charting the heavens, a legacy of clarity amid the cosmos. In doing so, Edmund Halley didn't just observe the stars. He gave them context, location, and meaning. He turned the night sky into a structured map, navigable and knowable. And in the process, he brought humanity one step closer to understanding its place among the stars. Episode 5: The Sea, the Stars, and the Winds. Halley's Naval Expeditions. By the late 1690s, Edmund Halley's reputation as an astronomer and scientific thinker had solidified. But ever restless, he turned his gaze toward another frontier, the vast and unpredictable seas. His fascination with the natural world extended beyond the stars. Halley believed that understanding Earth's oceans, winds, and magnetic fields was just as vital to science as understanding the heavens. In 1698, Halley embarked on one of the most unusual chapters of his life. He became a sea captain. Though not a trained sailor, he convinced the Admiralty to grant him command of a specially outfitted ship, the Paramour, making him one of the first scientists to receive a naval commission solely for the purpose of conducting research. This bold decision marked a new era in British scientific exploration, where ships were no longer just vessels of war or trade, but also floating laboratories. Halley's mission was multifaceted. He sought to chart the variation of Earth's magnetic field across the Atlantic, to investigate the patterns of prevailing winds, and to gather data that could help sailors navigate more safely. He understood that accurate knowledge of magnetism and currents could mean the difference between life and death for ships at sea. His first voyage in 1698 took him south along the coast of Africa, then across the Atlantic toward the Americas. Along the way, Halley measured the magnetic declination, the angle between magnetic north and true north, at various points, noting how it changed across different regions. These measurements were among the first systematic efforts to understand the invisible forces that influence compasses. But Halley's journey wasn't without challenges. His crew, unused to being commanded by a scientist, mutinied early in the voyage, accusing him of incompetence. Undeterred, Halley returned to England, cleared his name, and set out again with a new crew and renewed determination. Over the next 2 years, he conducted multiple expeditions, gathering a wealth of data that would become the basis for the first magnetic charts of the Atlantic. These charts were revolutionary. For the first time, sailors had a visual guide showing how magnetic north varied across the ocean. Halley's general chart of the variation of the compass, published in 1701, used lines, now called isogonic lines, to connect points of equal magnetic variation. It was a foundational step toward the modern science of geomagnetism. In addition to magnetism, Halley observed atmospheric conditions, ocean currents, and temperature changes. His notes included careful logs of barometric pressure, wind patterns, and even bioluminescent phenomena in the sea, an early form of what we now call oceanography. What's remarkable about this period of Halley's life is how seamlessly he transitioned from the observatory to the ocean. He treated the sea as an extension of the heavens, a place where patterns and principles could be discovered through careful observation and measurement. To Halley, the laws of nature were universal, whether they governed stars or tides. His naval expeditions also reflected a growing idea of science as an exploratory and empirical endeavor, no longer confined to dusty libraries or elite universities. Scientists like Halley ventured into the world, using the tools of navigation, astronomy, and mathematics to decode the environment around them. These voyages were not just scientific missions. They were bold statements that knowledge was worth the journey, even if that journey crossed stormy seas. When Halley finally retired from his seafaring days, he returned not as an adventurer, but as a scientist whose findings had real, practical impact. Sailors used his charts. Scientists used his data. The Royal Navy had helped open a door to scientific exploration, and Edmund Halley had walked through it with confidence and curiosity. As he stepped back onto dry land, Halley carried with him not just nautical logs and magnetic readings, but a deeper understanding of how Earth itself, like the stars above, was part of a vast interconnected system, one that could be observed, measured, and perhaps, in time, fully understood. Episode 6: A Celestial Legacy. The birth of Halley's Comet. By the early 1700s, Edmund Halley had already accomplished more than most scholars could dream of. He had mapped the stars, sailed to the oceans, and contributed to some of the most important scientific works of his age. Yet, one of his greatest achievements was still to come, a discovery that would forever etch his name in the night sky. Halley's fascination with comets wasn't new. These luminous, transient visitors from the cosmos had captured human imagination for millennia. They were often seen as omens, heralds of change, disasters, or divine messages. But Halley approached them differently. He saw them not as signs from the gods, but as celestial objects obeying the same natural laws that govern the planets and moons. Armed with the tools of Newtonian mechanics, Halley began analyzing historical records of comet appearances. In particular, he focused on 3 bright comets observed in 1531, 1607, and 1682. These events had been widely recorded, and Halley noticed something striking. The paths of these comets were remarkably similar. Using Newton's laws of gravitation, Halley calculated the orbits of each of these comets and realized they might not be separate entities at all. He proposed boldly that these were repeated appearances of the same comet, following a highly elliptical orbit around the Sun, with a period of roughly 76 years. This was revolutionary. No one had ever proven that a comet could return in a regular, predictable fashion. Halley didn't just suggest it, he made a daring prediction. He stated that the comet observed in 1682 would return again around the year 1758. And though Halley knew he would not live to see it, he placed his trust in the mathematics. "If it should return," he wrote, "according to our predictions, impartial posterity will not refuse to acknowledge that this was first discovered by an Englishman." This was more than scientific pride. Halley's prediction was a test of Newtonian physics itself. If the laws held true not only for planets but for comets as well, it would confirm the universality of the gravitational force. Halley's work reflected a profound shift in how humanity understood the cosmos. In earlier centuries, comets were mysteries, wild, untamed phenomena that defied explanation. But now, under the lens of science, they became part of a grand ordered universe. The sky was no longer a realm of caprice and superstition. It was a realm of law and logic. When the comet did indeed return in 1758, as Halley had predicted, it was a moment of triumph, not only for astronomy, but for rational thought. The returning comet was named in his honor, Halley's Comet. Today, Halley's Comet remains one of the most famous comets in history. It is the only short-period comet visible to the naked eye from Earth, and has appeared in countless historical records, tapestries, and even ancient artwork. Every 76 years or so, it graces our skies, its glowing tail sweeping across the heavens like a silent tribute to the mind that first unlocked its secret. But Halley never saw his namesake return. He died in 1742, 16 years before the comet's predicted reappearance. Yet his legacy endures not just in the comet, but in the way we understand the universe. His work showed that with curiosity, patience, and reason, even the most elusive wonders of the night sky could be brought into the realm of human understanding. As we look up at Halley's Comet on its next return, whether in our lifetime or in generations to come, we are not just watching a ball of ice and dust racing through space. We are witnessing the fulfillment of a vision, the echo of a prediction, and the enduring legacy of a man who believed that the universe could be known. And through that belief, Halley gave the stars a new voice, one that speaks through science, discovery, and wonder. Episode 7: Halley's Influence. Across the centuries, although Edmund Halley never lived to witness the return of the comet he predicted, his work sent ripples through the centuries. When Halley's Comet appeared in 1758, it marked a turning point in the history of science. The confirmation of its return was not merely the validation of a single man's hypothesis. It was the validation of a worldview. The universe, once ruled by myth and mystery, was increasingly seen as a place governed by discoverable laws. The return of Halley's Comet was observed with great excitement by astronomers across Europe. The German astronomer Johann Georg Pallich was the first to spot it on Christmas Day, 1758. His sighting was not only a celebration of observational skill, it was a fulfillment of Halley's legacy, made possible by his vision and the tools of Newtonian physics. the comet's return had been more than a scientific curiosity. It demonstrated that comets, once regarded as unpredictable, could be placed within a larger cosmic framework. This opened the door to cometary science as a discipline, an area that continues to yield discoveries about the early solar system and the building blocks of life. Halley's impact didn't end with his comet. His approach to science, combining observation, historical analysis, and mathematics, became a model for generations of researchers. In many ways, Halley helped define what it meant to be a modern scientist. Not only a gatherer of facts, but a weaver of patterns, someone who seeks out the invisible threads that bind the cosmos together. In the 19th and 20th centuries, Halley's Comet continued to capture public imagination. Its 1835 return was observed with improved telescopes, and its 1910 passage brought global anticipation and a fair amount of anxiety. Some people feared the comet's tail, which was projected to pass through Earth's orbit, would bring toxic gases. Entrepreneurs even sold comet pills to ward off supposed poisons. The Earth did, in fact, pass through part of the comet's tail, but with no harmful effects, only awe. Then, in 1986, during its next visit, Halley's comet was observed not only from Earth, but also from space. Several spacecraft were sent to study it closely, including the European Space Agency's Giotto probe, which made a daring close approach to the comet's nucleus. For the first time, humanity saw detailed images of a comet's core, a dark, icy body emitting streams of gas and dust into the void. This moment was emblematic of how far science had come since Halley's time. The same comet he traced through ancient records had now become an object of direct exploration, linking 17th century astronomy with the space age. Throughout its appearances, Halley's comet has become a cultural icon. It has been featured in ancient Chinese chronicles, medieval European tapestries, and even art by Giotto di Bondone, whose adoration of the Magi may depict the comet's 1301 visit. In modern times, it has appeared in music, literature, and films, always as a symbol of wonder, change, or destiny. But at the heart of all this lies Halley himself, a man who saw beyond the chaos of the sky and into its rhythm. He took something once feared and made it part of an ordered universe. In doing so, he brought the stars a little closer. His influence stretches beyond astronomy. Halley's interdisciplinary work in meteorology, magnetism, oceanography, and geophysics reflected a deep belief in the unity of knowledge. He helped lay the foundation for collaborative science, where insights from different fields build a more complete understanding of our world. In each return of Halley's comet, there is a quiet echo of his spirit. The silent arc of its journey is not just a cosmic event, it's a remembrance, a celebration of the human capacity to learn, to predict, and to dream. As we continue our exploration through Halley's story, we are reminded that science is not just about formulas and calculations. It is a human endeavor, rooted in curiosity and sustained by the courage to ask the biggest questions. Episode 8: Mapping the Skies. Halley's Southern Expedition. In the late 17th century, much of the southern sky remained a mystery to European astronomers. Most star charts were based on observations from the northern hemisphere, leaving The skies of the south incomplete, misrepresented, or entirely blank. Edmund Halley, ever drawn to the unknown, saw this as an opportunity to extend the reach of science into uncharted celestial territory. In 1676, at just 20 years old, Halley set sail for the remote island of St. Helena in the South Atlantic Ocean. Sponsored by the Royal Society and encouraged by King Charles II, this journey was more than a youthful adventure. It was a mission of astronomical importance. With a telescope, a sextant, and unwavering resolve, Halley intended to map the southern constellations with the same precision as those of the north. The conditions were far from ideal. St. Helena's unpredictable weather often obscured the skies, and the island's isolation meant Halley was cut off from communication for over a year. Yet, amid wind and rain, he persisted. Night after night, he measured star positions, slowly building a comprehensive map of the southern sky. His dedication yielded results. He recorded the positions of over 340 stars, many of which had never before been catalogued by European astronomers. In 1678, Halley published Catalogus Stellarum Australium, or Catalogue of Southern Stars, a landmark work that filled a significant gap in astronomical knowledge. For his efforts, he was awarded an honorary degree from Oxford, an unusual recognition at the time, particularly for someone who had left the university without completing his formal studies. But Halley's observations on St. Helena were not limited to stars. He also took note of the island's weather patterns, laying the foundation for later studies in meteorology. His records included observations of trade winds and barometric pressure, which he would later incorporate into broader theories about the Earth's atmosphere. His southern expedition exemplified his scientific spirit, fearless, thorough, and endlessly curious. At a time when travel was perilous and knowledge fragmented, Halley was part of a generation of thinkers who believed that the world and the cosmos could be understood through careful observation and shared knowledge. Upon returning to England, Halley's contributions were widely celebrated. More than just a star catalogue, his work represented a new chapter in global science. By charting the skies of the Southern Hemisphere, he helped unify humanity's view of the heavens. No longer were the stars the province of the North, they belonged to the entire Earth. Halley's catalogue became an essential reference for future astronomers and navigators. Sailors, explorers, and scientists alike used his star charts to guide their journeys across oceans and continents. In this way, Halley's work connected the stars not only to science, but also to the pulse of exploration, trade, and communication. This journey, early in Halley's career, reveals much about the man behind the comet. His brilliance was matched by determination, and his love for the sky was grounded in meticulous work. He saw the act of mapping the stars not as a conquest, but as a collaboration with nature, a quiet dialogue between the human mind and the infinite universe above. As we continue our journey through his life and legacy, we begin to see Halley not only as the comet's namesake, but as a pioneer of modern science whose contributions shine in many corners of knowledge. From the constellations of the Southern Hemisphere to the mysteries of magnetic fields, his fingerprints are everywhere, in the maps we draw, the orbits we trace, and the questions we continue to ask. Episode 9, The Magnetic Earth, Halley's theory of the inner world. After his astronomical successes, Edmund Halley turned his gaze downward, from the stars above to the planet beneath our feet. Always curious, he was fascinated by the invisible forces shaping the Earth, especially magnetism. At the time, compass navigation was vital for seafaring nations like England. But the behavior of magnetic variation, the angle between magnetic north and true north, remained poorly understood. Halley saw an opportunity to shed light on one of nature's most elusive phenomena. In 1698, with the backing of the British Admiralty, Halley embarked on yet another ambitious journey, this time as the captain of a ship, the Paramour. His mission was to measure the magnetic declination in various parts of the Atlantic Ocean. For a scientist, it was a rare privilege and a sign of great respect to be entrusted with command of a Royal Navy vessel. Halley's voyage was both scientific and symbolic, an exploration of the Earth's hidden energies. During his journey, he made detailed observations of the magnetic field and created the first isogonic charts, maps showing lines of equal magnetic declination. These charts provided sailors with critical data for correcting their compass readings, improving navigation, and increasing safety at sea. It was a major leap forward in maritime science and demonstrated Halley's unique ability to combine theoretical knowledge with practical application. But Halley's imagination didn't stop there. In 1692, years before this voyage, he had proposed one of the most intriguing and speculative theories of his career: the hollow Earth. According to Halley's hypothesis, the Earth was composed of a series of concentric spheres, an outer shell and 2 or 3 inner shells, each rotating independently and possibly inhabited. He believed this structure could explain irregularities in magnetic variation. Halley's theory was, of course, controversial. Many scientists of his time and later rejected the idea of a hollow planet. Yet, what stands out is not the accuracy of the theory, but the boldness of the question. Halley dared to propose a model that challenged conventional thinking, rooted not in fantasy, but in his effort to explain real, observable phenomena. Even today, the hollow Earth theory captures the imagination of writers, dreamers, and science fiction enthusiasts. But in Halley's time, it was a serious attempt to grapple with mysteries still unsolved. It shows how, even as a rigorous scientist, Halley never stopped entertaining the possibilities that lay just beyond accepted knowledge. His work on magnetism had lasting impact. Though later scientists would refine and expand upon his findings, Halley's magnetic surveys laid the groundwork for the study of geomagnetism, a field crucial to modern geology, navigation, and even space science. The Earth's magnetic field protects our planet from solar radiation and helps orient both birds and satellites. Halley's curiosity was centuries ahead of its time. By exploring magnetism, Halley revealed another side of his genius. He wasn't confined to the heavens nor satisfied with only observing stars. He wanted to understand the forces that governed all things, from the distant motion of comets to the inner workings of our world. He believed that science should reach into every corner of the universe, seen and unseen. In every voyage, every theory, Halley was driven by an insatiable desire to know. His journey into Earth's magnetism may not have led to hidden worlds beneath our feet, but it did illuminate the invisible threads that hold our planet together. And in doing so, Halley brought us one step closer to understanding the delicate balance of the cosmos and our place within it. Episode 10, Halley and Newton, a friendship that changed the universe. As much as Edmund Halley was an explorer of oceans and skies, his most enduring contribution to science may well have been a single act of belief in another man's genius. This man was Isaac Newton, and Halley's unwavering support of Newton would help change the course of human understanding forever. In the mid-1680s, the scientific world was buzzing with questions about planetary motion. What laws governed the movements of the planets? Why did they orbit the sun in ellipses? Many mathematicians and astronomers had attempted to explain these motions, but none had yet uncovered the universal truth behind them. It was during this time that Halley, already a respected figure in the scientific community, sought out Newton at Cambridge. Newton had retreated into seclusion, quietly working through his own theories of motion and gravity. When Halley visited him in 1684 and posed a simple question, what kind of force would cause the planets to move in ellipses? Newton's answer astonished him. An inverse square force, Newton said, and he claimed to have proved it. That conversation changed everything. Realizing the importance of Newton's findings, Halley encouraged him to write them down formally. But Newton, ever cautious and deeply private, had no plans to publish. Halley persisted. He visited Newton repeatedly, coaxed the ideas into fuller form, and even mediated when Newton had intellectual disputes with other scientists. Perhaps most significantly, when Newton finally agreed to write his magnum opus, Philosophiae Naturalis Principia Mathematica, or simply the Principia, it was Halley who took on the role of editor, promoter, and publisher. The Royal Society had run out of funds to support the printing, but Halley financed the publication himself. He even paid for the diagrams and distribution out of his own pocket. The Principia, published in 1687, became one of the most influential works in the history of science. It laid out the laws of motion and universal gravitation, offering a framework that would shape physics for centuries to come. Without Halley's encouragement and resources, this masterpiece may never have seen the light of day. This act of friendship and intellectual trust is one of the great moments in scientific history. Halley was not merely a facilitator. He recognized the brilliance of Newton's ideas and did everything in his power to ensure they reached the world. It speaks volumes about Halley's character, generous, visionary, and deeply committed to the advancement of knowledge. But the story doesn't end there. The Principia was not just Newton's triumph. It was a foundation upon which Halley would continue to build. The laws described within helped Halley calculate the elliptical orbit of the comet that would bear his name. Newton gave Halley the mathematical tools, and Halley, in turn, gave Newton a reason to share them. Their relationship was not without tension. Newton could be difficult, and the pressures of publication were immense, but their collaboration stands as a testament to what can happen when brilliant minds come together in pursuit of a greater truth. In this episode of his life, Edmund Halley proved that discovery isn't always about being the first to see something. It can also be about ensuring that the truth is heard, understood, and remembered. Halley's role in bringing Newton's vision to the world was as crucial as any of his own scientific accomplishments. It reminds us that behind every great revolution in knowledge, there are often quiet champions, those who see the potential in others and work tirelessly to bring it to life. In Halley's story, we find one such champion, whose faith in a friend helped unlock the very laws that govern the stars. Episode 11, Halley's Legacy in Astronomy, Mapping the Heavens. Edmund Halley is most famously remembered for the comet that bears his name, but his contributions to astronomy extend far beyond the prediction of celestial orbits. In the quiet hours under the vast night sky, Halley found meaning in the patterns of the stars. With the precision of a navigator and the soul of a philosopher, he began to map the heavens, not merely as a scientist, but as a man fascinated by the order of the cosmos. One of Halley's earliest astronomical projects was an ambitious star catalogue. In 1676, at just 20 years old, he sailed to the remote island of St. Helena in the South Atlantic. The southern skies were largely uncharted by European astronomers, and Halley aimed to fill that gap. Battling stormy seas and a harsh climate, he remained on the island for more than a year, carefully charting the positions of 341 stars in the southern hemisphere. The result, Catalogus Stellarum Australium, was published in 1679 and marked a milestone in celestial cartography. It earned Halley comparisons to Tycho Brahe and even the title the Southern Tycho. His work expanded the known map of the heavens and established his reputation among the leading astronomers of his time. But Halley's gaze didn't stop with stars. He was equally fascinated by what moved through them. His later work involved the detailed observation of the moon and the sun. He studied eclipses, sunspots, and solar cycles. He understood that the skies were not static but dynamic, and he sought to reveal the invisible laws that govern their motion. Halley also predicted that a total solar eclipse would occur over England in 1715, calculating its path with remarkable accuracy, a feat that astonished his contemporaries and demonstrated the growing power of mathematical astronomy. In addition to charting celestial bodies, Halley made critical contributions to understanding their movement over time. He studied the proper motion of stars, how their positions subtly shift across centuries. Comparing ancient star catalogues with his own measurements, he identified that stars were not fixed in space, as had been believed for generations. Instead, they moved independently, revealing the vast kinetic structure of the universe. These discoveries laid the groundwork for the future of stellar astronomy and hinted at the galaxy's rotation long before it could be fully understood. Once again, Halley was ahead of his time. He also played an instrumental role in improving methods for determining longitude, a critical need for both navigation and astronomical observation. By proposing the use of lunar distances, measuring the position of the moon relative to background stars, Halley offered a practical method that would be refined and widely adopted in the centuries that followed. Through his tireless observations, Halley showed that the sky was not merely a canvas of beautiful lights, but a clockwork of immense precision and power. He helped humanity move from myth and superstition into an era of measurement and understanding. Perhaps most importantly, Halley's legacy in astronomy was one of curiosity, relentless, humble, and ever-expanding. He didn't seek the spotlight, but rather the truth that lay hidden in the stars. He believed that by understanding the cosmos, we might better understand our place within it. In every map he drew, in every orbit he calculated, Halley left behind a vision of the heavens not as unknowable, but as a puzzle to be solved with patience and wonder. And in doing so, he illuminated the path for all who would follow, astronomers, dreamers, and explorers of every kind. Episode 12: Halley and the Magnetic Field. Charting the invisible, though best known for his celestial pursuits, Edmund Halley's curiosity extended beyond the stars. He was deeply fascinated by the hidden forces of nature, those unseen threads that connected Earth and sky. Among these, Earth's magnetic field captured his attention in a profound way. In a time when magnetism was still a mystery wrapped in speculation, Halley sought to understand and map its presence across the globe. In 1698, Halley embarked on a groundbreaking voyage commissioned by the English Admiralty aboard a small warship named the Paramour. His mission was unprecedented: to study Earth's magnetic field across the Atlantic Ocean. It was a bold scientific expedition, and one of the first in history undertaken for a purely scientific purpose rather than exploration or conquest. During this voyage, Halley meticulously recorded magnetic declinations, the angle between magnetic north and true north, at various points along his journey. These measurements would help sailors understand how their compasses could lead them astray, depending on their location. By correcting for these variations, navigation would become safer and more accurate. In 1701, Halley published the first magnetic declination chart of the Atlantic, an elegant map filled with flowing lines now known as isogonic lines. Each line connected points of equal magnetic variation. It was a visual revolution, magnetism made visible through the power of geometry and observation. This achievement placed Halley among the founders of geomagnetism, the study of Earth's magnetic field. He had taken something invisible and given it form, mapped it, explained it, and made it useful to those who relied on the sea. But Halley did not stop at observation. He also speculated on the origin of Earth's magnetism. In one of his most imaginative hypotheses, he proposed that Earth might be composed of concentric hollow shells, each rotating independently and perhaps containing its own magnetic poles. While this theory was later disproven, it showcased Halley's boldness in exploring the unknown. He was not afraid to ask big questions, even if the answers were beyond the reach of his time. His ideas influenced thinkers for generations. Some aspects of his hollow Earth theory even inspired later writers of science fiction. Yet Halley's intent had always been scientific. He was a man navigating the twilight between myth and measurable reality, helping to steer science into a new age. Magnetic Field Project also reflected Halley's practical nature. He wasn't content to gaze at the heavens. He wanted to apply his knowledge to everyday life. He understood that scientific insight could serve real-world needs, guiding ships, preventing disasters, and enabling a deeper understanding of our planet. Through this endeavor, Halley helped expand the boundaries of navigation, geophysics, and our understanding of the planet itself. He saw Earth not as separate from the cosmos, but as a dynamic part of a larger system, spinning, shifting, magnetic, and alive. Halley's work on the magnetic field reminds us that exploration is not always about distant worlds. Sometimes, The most mysterious frontiers lie beneath our feet, invisible but powerful. And it takes a mind like Halley's to chart such realms with clarity and courage. Episode 13. Halley's influence on Newton. A friendship that shaped the cosmos. While Edmund Halley's name is often linked to his famous comet, one of his most enduring contributions to science lies in a friendship that transformed our understanding of the universe. That friendship was with Isaac Newton. In the 1680s, the world of astronomy was at a crossroads. Johannes Kepler had provided powerful observational laws describing planetary motion, but no one had yet explained why planets moved the way they did. The mathematical force underlying gravity remained a mystery. It was in this atmosphere of unanswered questions that Halley took a fateful journey to Cambridge in 1684. He was searching for an explanation for the laws of planetary motion, and sought out Newton, who had by then retreated from public academic life. In conversation, Newton casually mentioned that he had solved the problem, that planets move in ellipses due to a central inverse square force, which he had already calculated. Halley, astonished, asked for details. Newton, equally surprised at Halley's interest, agreed to send him the calculations. What followed was a series of letters, discussions, and encouragements that culminated in one of the most significant books in the history of science, Philosophiae Naturalis Principia Mathematica, or simply the Principia. But this monumental work might never have seen the light of day without Halley. Newton had no intention of publishing it. It was Halley who recognized its value, who pushed Newton to write it fully, and who personally financed its publication when the Royal Society could not afford it. The Principia, published in 1687, laid the foundation for classical mechanics. It introduced Newton's laws of motion and universal gravitation, principles that would govern scientific thought for over 2 centuries. Halley's support was not limited to money. He acted as editor, intermediary, and even peacemaker when Newton's disputes with other scientists threatened progress. Halley's role was more than that of a friend. He was a catalyst. Without his persistence, the laws that describe the motion of planets, moons, and falling apples might have remained hidden in Newton's notebooks. His belief in science, in discovery, and in Newton's genius helped give birth to a new scientific age. Their collaboration wasn't just academic, it was personal. They respected each other's minds and shared a commitment to uncovering nature's truths. Halley brought Newton's ideas into the world, and Newton gave structure to the questions that Halley and others had long been asking. Through this alliance, Halley left a legacy not only in his own discoveries, but in the work of others. He was a bridge between generations of thinkers, between observation and theory, between inspiration and execution. It is rare in history to find someone who both generates profound insights and elevates the work of others. Halley did both. Citoyen, his encouragement of Newton, he gave the world a gift greater than any comet. He helped illuminate the very laws that govern them. Episode 14. Mapping the Skies. Halley's Southern Star Catalogue. Beyond his cometary fame and his collaboration with Newton, Edmund Halley left a lasting legacy as a cartographer of the stars. At a time when the Southern Hemisphere remained largely uncharted in the European scientific world, Halley undertook an ambitious voyage that would illuminate a previously hidden portion of the cosmos. In 1676, at just 20 years old, Halley set sail for the island of St. Helena, a remote British outpost in the South Atlantic Ocean. His mission was extraordinary for its time, to catalogue the stars of the southern sky with precision and detail never before achieved by a European astronomer. Equipped with a sextant and a telescope, Halley spent nearly 2 years enduring tropical storms, variable weather, and isolation. His nights were spent peering through the telescope, measuring positions, brightness, and angles. By the end of his expedition, he had recorded the positions of 341 southern stars, many of which had never been accurately charted before. In 1679, he published Catalogus Stellarum Australium, the catalogue of southern stars. This remarkable document earned him the nickname the Southern Tycho Brahe, in reference to the famed Danish astronomer known for his accurate star observations. Halley's catalogue didn't merely fill in gaps in celestial maps. It extended humanity's vision beyond the familiar northern sky and laid a foundation for global astronomy. Before his work, European charts of the heavens were biased toward the constellations, visible from their latitudes. Halley made the sky whole. This journey marked the beginning of a career defined by exploration, not just of distant skies, but of methods, ideas, and frontiers of science. His work on St. Helena revealed the necessity of accurate star mapping for navigation, timekeeping, and understanding the universe's structure. His catalogue was more than a list. It was a testament to observation and perseverance. He identified constellations like Centaurus, Hydrus, and Volans, and established a clearer view of the Southern Cross, a constellation of profound cultural significance in the Southern Hemisphere. Halley's star chart also provided valuable data for future astronomers. It enabled them to compare stellar positions over time and uncover the phenomenon of proper motion, the slow, actual movement of stars across the sky. Although Halley would later be the first to describe this effect formally, his early observations planted the seeds. As he looked up from St. Helena, Halley wasn't just recording points of light. He was extending the boundaries of known space, giving humanity a more complete picture of the universe it inhabited. In doing so, he joined the ranks of explorers who, with compass and sextant, transformed mystery into map. It's humbling to consider the ambition of this young astronomer, charting the southern skies with handcrafted instruments and a heart full of wonder. The night sky, he revealed, is the same that shines above us today. A shared canopy of stars, once unknown, now mapped by a curious mind determined to bring the heavens closer. Episode 15, The Magnetic Earth, Halley's Theories and Voyages. While Edmund Halley is celebrated for his astronomical achievements, his curiosity extended far beyond the stars. One of his lesser-known but equally impressive contributions was to the study of Earth's magnetic field, a subject that fascinated him deeply and led him on daring expeditions across the Atlantic. In the late 17th century, navigators relied heavily on magnetic compasses, but the variation or declination between true north and magnetic north remained a mystery. These discrepancies were not consistent across regions or over time, causing confusion and error in long voyages. Halley saw in this problem a challenge worthy of his intellect. In 1698, he proposed a groundbreaking idea that the Earth might contain multiple magnetic poles and even concentric spherical shells inside its core, each rotating at different speeds. This speculative model was Halley's attempt to explain irregular magnetic readings reported by sailors. To investigate further, he took to the sea once more. Under royal commission, Halley was given command of a ship, the Paramour. This was extraordinary, as he became the first civilian scientist to be granted such authority by the British Admiralty. Between 1698 and 1700, Halley undertook 2 voyages in the Atlantic, during which he systematically measured magnetic declination at various points, from the Azores to the coast of Africa. These voyages were no easy feat. Halley faced challenges of navigation, crew management, and equipment maintenance, all while trying to gather consistent scientific data. Yet, his perseverance paid off. Upon returning to England, he published the first magnetic declination chart of the Atlantic Ocean in 1701, a map that showed how the compass needle deviated from true north in different parts of the sea. This chart was revolutionary. For the first time, sailors could correct their compass readings with reference to their location, improving maritime navigation across the globe. It was a crucial step toward understanding Earth's magnetism and a precursor to the development of geomagnetic science. Halley's hypothesis about the Earth's inner structure, though speculative and eventually disproven, showed the depth of his imagination. He envisioned a hollow Earth with rotating inner shells, suggesting that shifts in these spheres could produce the irregularities in magnetism. He even speculated that life might exist within these hidden layers, a notion that would later inspire science fiction. But more important than his speculative model was Halley's method: systematic observation, data collection, and mapping. He believed that through meticulous study, nature's patterns could be revealed, even when the cause was not yet understood. His magnetic work influenced generations of scientists. It demonstrated the importance of fieldwork and the integration of theory with real-world data. Halley had become not only a stargazer, but an explorer of Earth's hidden forces, venturing into disciplines that today we would call geophysics. Through these expeditions, he once again showed that true discovery lies not just in answers, but in the questions brave enough to be asked, and the journeys bold enough to seek them. Episode 16. Halley and the Longitude Problem. In the age of exploration, determining a ship's longitude at sea was one of the greatest scientific and navigational challenges. Latitude could be measured relatively easily by observing the sun or stars, but longitude, how far east or west one was, remained elusive. Errors in longitude could lead to disastrous outcomes, from shipwrecks to missed destinations. It was a problem that stumped the best minds of the era. Edmund Halley was one of them. Halley recognized that accurate navigation was not only a practical necessity for maritime empires like Britain, but also a scientific puzzle. During his voyages, he observed firsthand how discrepancies in time and position could affect a ship's course. Inspired by these experiences, he began investigating possible solutions to the longitude problem. One promising idea at the time involved using the positions of the moon and stars as a kind of cosmic clock. The moon moves predictably across the sky, and by carefully measuring its position relative to certain stars at a known time, navigators could, in theory, determine their longitude. This method, known as lunar distance, required extremely accurate lunar tables and precise instruments. Halley devoted considerable effort to developing both. As royal astronomer, Halley improved astronomical instruments and worked on refining tables that predicted the Moon's position. He published several works detailing lunar motion, correcting errors in earlier models. Though the method was too complex for many sailors to use effectively in his lifetime, Halley's groundwork was crucial. It paved the way for later developments that would make the method viable, especially when combined with accurate timekeeping. Halley's efforts also influenced the British government's growing interest in solving the longitude problem. In 1714, shortly after Halley's key contributions, Parliament passed the Longitude Act, offering a substantial reward for anyone who could devise a reliable way to determine longitude at sea. This led to intense competition and innovation, including the eventual invention of the marine chronometer by John Harrison. While Halley did not solve the problem outright, his contributions were indispensable. He showed that astronomical observation could play a role, and his lunar tables were among the most accurate of the time. In a sense, he bridged the gap between raw theory and applied science, pointing the way forward for those who would eventually succeed. What makes Halley's involvement in the longitude question so remarkable is how it exemplifies his approach to science. Interdisciplinary, exploratory, and always guided by a sense of practical purpose. Whether charting the heavens or navigating the seas, he sought not only to understand nature's rules, but also to use them to benefit humanity. His work on longitude also shows how deeply connected his astronomical insights were to everyday challenges. The sky for Halley was not just a realm of wonder, it was a tool, a guide and a compass. And with it, he helped shape the course of history, steering ships, scholars and science towards new horizons. Episode 17. Halley and the Aurora. Borealis, among the many natural phenomena that fascinated scientists of the 17th and 18th centuries, few were as mysterious and captivating as the Aurora Borealis, or Northern Lights. Glowing curtains of green, red and purple light that danced across the night sky in polar regions. These ethereal displays sparked both awe and confusion. Edmund Halley, always curious and methodical, took a deep interest in the phenomenon and was among the first to attempt a scientific explanation. In 1716, an especially brilliant auroral display illuminated the skies over England, visible as far south as London. Halley, by then in his early 60s and serving as Astronomer Royal, took the opportunity to observe it carefully. Unlike many of his contemporaries, who viewed such events as omens or divine messages, Halley approached the aurora with scientific curiosity. He documented the brightness, movement, and color of the aurora, noting its appearance in relation to Earth's magnetic field. Based on his observations, Halley proposed that the aurora was caused by magnetic interactions in the Earth's upper atmosphere. He suggested that particles or vapors rising from the Earth were affected by magnetic forces, creating light through friction or electrical effects. While not entirely accurate by modern standards, Halley's hypothesis was remarkably advanced for his time. It marked one of the earliest attempts to connect auroras with Earth's magnetism, an idea that would eventually lead to the correct understanding of how solar winds interact with the planet's magnetosphere. What's particularly notable is how Halley's approach exemplified the early scientific method. He sought patterns, gathered data, and used analogies from other areas of physics to form a working model. He didn't claim absolute certainty, but instead offered a framework others could build upon, a key hallmark of genuine scientific progress. Wushu's interest in geomagnetism wasn't new. Earlier in his career, Halley had created one of the first comprehensive maps of Earth's magnetic declinations, charting the variation of magnetic north across the globe. This was a vital resource for navigation and showed how Earth's magnetic field varied in both space and time. Halley's insights into magnetism and his auroral observations helped open the door for later scientists like Christian Birkeland and Carl Sturmer to fully explain the phenomenon in the 19th and 20th centuries. Today, we understand auroras as a result of charged particles from the sun striking atoms in Earth's upper atmosphere, exciting them and causing the glowing display of light. But in Halley's time, to even suggest that terrestrial magnetism and space phenomena were connected was bold and visionary. He helped lay the groundwork for space weather science, long before humanity had ever left Earth. His work on auroras also illustrates the poetic blend of wonder and reason that defined his worldview. To Halley, the beauty of the aurora wasn't diminished by explanation, it was enhanced. Understanding the mechanisms behind nature's spectacles was, in his view, a way of honoring their majesty, not reducing it. In his writings, Halley showed reverence for the vastness and mystery of the cosmos, but never shied away from the challenge of uncovering its laws. The aurora borealis, shimmering silently above him, became yet another lens through which he pursued the infinite. Episode 18: Halley's Influence on Future Generations. As Edmund Halley aged, his reputation as one of the most versatile and forward-thinking scientists of his era only grew. His influence extended far beyond his immediate discoveries, touching the lives and minds of generations of astronomers, mathematicians, and natural philosophers. Even in his later years, Halley continued to write, mentor, and inspire, leaving behind not just papers and predictions, but a legacy of intellectual bravery and curiosity. One of Halley's most enduring contributions to science was his belief in collaboration and communication. He was deeply connected to the broader scientific community of Europe, exchanging letters with leading thinkers such as Gottfried Wilhelm Leibniz and Christian Huygens. He helped elevate Isaac Newton's Principia Mathematica, not only by urging its publication, but also by financing it and editing parts of it. Without Halley, Newton's laws might have remained buried in notebooks rather than reshaping the world. By facilitating Newton's work, Halley didn't just promote a friend's ideas, he pushed forward the entire scientific revolution. Newton's law of universal gravitation, which Halley recognized as groundbreaking, became the bedrock upon which celestial mechanics were built. Halley's own computations of comet orbits used Newtonian physics to predict future appearances of what would later be named Halley's Comet, proving the validity of Newton's ideas through real-world application. Halley's open-mindedness also distinguished him. While grounded in observation and reason, he remained receptive to new ideas, even controversial ones. His theory about the hollow Earth, for example, while incorrect by modern standards, exemplifies a willingness to hypothesize boldly. His speculation was not driven by fantasy, but by a genuine attempt to reconcile puzzling magnetic data with the best tools and knowledge available at the time. Future scientists admired Halley for this very trait: his ability to imagine beyond the known, to push the edges of understanding while staying tethered to evidence. In this way, he became a model for later pioneers like Laplace, Herschel, and even Einstein, men who reshaped the way humanity viewed the universe by daring to question assumptions. Halley also contributed significantly to the infrastructure of science. As Astronomer Royal, he conducted meticulous observations of the moon and stars to improve navigation, timing, and calendar systems. His lunar tables, for instance, were later used by mariners and explorers across the world. Even long after his death, Halley's charts and methods helped guide ships across vast oceans and assisted in the calculation of celestial events. The Halleyan legacy is also visible in how we study and categorize comets. Before him, these wandering stars were feared as harbingers or considered unpredictable. By proving they followed orbits and obeyed physical laws, Halley demystified them, transforming them from omens into scientific phenomena. His prediction of the comet's return in 1758, 16 years after his death, was not just a triumph of astronomy, but a triumph of rational thinking over superstition. Today, when astronomers calculate planetary motions, track asteroids, or send spacecraft across the solar system, they are working in a world Halley helped create. He laid the intellectual groundwork for celestial navigation, planetary science, and space exploration, centuries before rockets or satellites existed. The craters on the Moon and on Mars named Halley are more than mere commemorations. They are markers of a legacy etched into the cosmos itself. And each time the comet Halley returns, every 76 years, the skies remember the man who first tamed its mystery. In the next episode, we will explore the 1758 return of Halley's comet, an event that fulfilled his prophecy and sealed his place among the stars. Episode 19. The Triumphant Return, 1758. The waning days of 1758, a quiet revolution took place in the night sky. Astronomers across Europe peered through their telescopes, some skeptical, others hopeful, as a familiar celestial visitor edged back into view. For those who understood its significance, the reappearance of this comet was more than an astronomical event. It was the fulfillment of a prophecy, the triumph of science over centuries of fear and myth. The comet had returned, just as Edmund Halley had predicted. Although Halley himself had passed away in 1742, his bold forecast was finally coming to life. In his 1705 paper, Synopsis of the Astronomy of Comets, he had analyzed historical sightings and calculated that the comets observed in 1531, 1607, and 1682 were not separate entities, but rather the same object, returning approximately every 76 years. He predicted that it would be seen again in late 1758 or early 1759. And now, to the amazement of many, it was happening. The actual sighting occurred on December 25th, 1758, when a German farmer and amateur astronomer named Johann Georg Palitsch detected the object in the constellation of Cancer. Palitsch had spent years preparing for this moment, poring over astronomical texts and refining his observational skills. His confirmation spread quickly, igniting both excitement and disbelief. What made this moment extraordinary was not simply that a comet had returned, but that its arrival had been predicted using mathematics and Newtonian physics. This was unprecedented. No one had ever successfully forecast the return of a comet before. Halley's posthumous success became an emblem of the power of rational inquiry and marked a pivotal moment in the history of science. Across Europe, astronomers and scholars celebrated the event. Many saw it as a vindication not only of Halley, but also of the broader scientific worldview that had begun to take root during the Enlightenment. The skies, once thought to be realms of divine mystery or unpredictable chaos, were now seen as systems governed by laws that humans could understand, calculate and use to foresee the future. In the years that followed, the returning comet became known universally as Halley's Comet, a rare honor, especially for a man who had not discovered it, but had instead revealed its nature. His name was now inseparable from the cosmic traveler he had studied so thoroughly, and with good reason. Every future appearance of the comet would bear the weight of his insight. Artists and poets of the time were also inspired. The comet's return became a symbol of reason's triumph, of humanity's expanding reach into the universe. Some likened it to a cosmic echo, a signal that human minds could grasp the rhythms of the heavens. Despite his absence from the physical world, Halley's presence was deeply felt. His prediction had crossed generations, linking his 17th century genius to the discoveries of the 18th century. It served as a message to future scientists: trust the evidence, follow the patterns, and dare to think beyond your lifetime. Even more profoundly, Halley's success changed the public perception of comets. No longer were they seen as portents of doom or harbingers of disaster. Their movements were now predictable, understandable, a part of the natural order rather than the supernatural. And so, in the crisp winter of 1758, as telescopes turned skyward and notebooks filled with fresh observations, a silent celebration unfolded across the scientific world. A man who had once stood on the shores of St. Helena, charting stars in isolation, now stood immortal in the annals of discovery. Halley's Comet had returned, and with it, the enduring power of curiosity and reason. In our next and final episode, we will reflect on Halley's legacy, how his life's work ripples through modern science, and how each appearance of his comet reconnects us to the awe and wonder that first drove him to look up at the stars. Episode 20: Legacy and Lasting Impact of Edmund Halley's Comet. As we reach the final chapter of our journey through the life and work of Edmund Halley, it is fitting to reflect on the profound legacy he left behind, not only in astronomy, but in the broader story of human curiosity and scientific endeavor. Halley's prediction of the comet's return transformed the way humanity views the cosmos. It marked a watershed moment when superstition gave way to reason, and celestial phenomena could be explained, anticipated, and embraced as natural parts of the universe's grand design. This shift paved the way for generations of astronomers and scientists who would follow, inspired by the knowledge that the universe, vast and mysterious, is also orderly and intelligible. Beyond his famous comet, Halley made crucial contributions to navigation, geophysics, and even demographics. His work in mapping the stars, calculating the Earth's magnetic field, and understanding trade winds helped shape the modern world in unexpected ways. The comet was his most famous achievement, but it was only part of a legacy marked by curiosity, rigor, and a tireless quest for understanding. Today, Halley's Comet continues to captivate millions around the globe every 76 years or so. Each appearance rekindles wonder and reminds us of the enduring human desire to explore and comprehend our place in the cosmos. It is a celestial messenger that links the past with the present and inspires the future. As you listen to this story, perhaps under a quiet night sky or the gentle glow of a bedside lamp, remember the spirit of Edmund Halley, an explorer not of new lands, but of the heavens themselves. His legacy invites us all to keep looking up, asking questions, and dreaming beyond the horizons of what we know. Thank you for joining this journey through history, science, and wonder. Until next time, keep your eyes on the stars.